Now, before I start off this video, I want to get through it quickly because it's the middle of the summer and it's pretty hot out there. And I'm wearing a jacket, so it's cool. I want to introduce you to a little character named Martin. Right here. You see him? Right, Martin is a cool fella. He likes climbing rocks, rock climbing, going up and down hills, going up mountains. And most importantly, kids, he does math. Let me see. Now today we're going to be learning about slope and the coordinate plane. First, we're going to go to a special place called slope land. Right there, slope land. Now, the first thing that you want to know about slope is it's the way of measuring the steepness of a line. Say if it's like very steep, very low, however it is. In mathematics, it can measure the rate of change. What type of function? Let's write that equation down. Slope equals n equals change in y or change x. Now let's start off simple by drawing a simple line through this coordinate plane that you might know. Let's see, there it goes like let's see, this. Yeah, that's very good. What we have right here is a line, something that never ends. It goes off infinitely in one direction and infinitely in the other. Wait a minute. Oh man, that outfit was very warm. Warm. Yeah. So here, slope land, Martin, this guy right here, does a lot of fun things. Using grappling hooks, which is like a famous Suicide Squad character you might have known. It's called a slipknot. Martin equals slipknot. right there. Wait, where was I? Alright, we drew the line. Yeah. So, say we... How do we do this? Yes. So, say right here. We start at the origin. That's what it's called, this little point. Origin equals 0, 0. So it's right here. When we have a line that's going up, you see this next point where it hits line. In fact, there's a bunch of points where it hits these like lines, both of them. We're gonna see how many like squares it passes until it gets to this other point. Let's see, one square from here to here. I'm trying to get to here, and it goes up 2. If we refer back to this, our slope equals the change in the y, which is how up and down it gets, and the change in x, which is side to side. You can see that the slope equals change in y 2 over change in x, which would be 1. Right, fairly simple. It's the slope. This can also be the same slope if, say, we did it from down here. If we went through these points. So this is going up. But what if we made it go down instead? Let's see. It can also go down, say like this. See, it crosses these two like lines right here, and here. You can measure the slope of this by doing the same thing we did with the other line. So it goes forward 1, and instead of going up, it goes down 3. But because it goes down, we add negative to indicate that it's going down. So the slope of this would be change in y, which would be -3, over change in x, which would be 1, meaning that the slope would be -3. Now these are 2 different slopes. We have 4 different types of slope, you might say. You see, this one that we just looked at is a negative slope. Negative, and the other one that we just did, the one that equals 2, is positive. Yeah. There are 2 more types. Now for that, we're going to look at these lines, so I don't have to erase any more lines. Yeah. Look at this. It goes up and down. See, what if that was a slope, a line? Let's see how forward it goes, back and forth, between this point and this point. With this point and this point. It goes up 2. It goes left and right 0. Now that 0 part is interesting, because if we put that in our equation, where the amount it goes up would be 2, and the amount it goes like left and right, the change in x, that would be 0. Now you might know from Richard Watterson's calculator game review that dividing by 0 is not a good thing. So what you get from dividing by 0 should be something not good, something undefined. Yeah, it's that. So that's the third type. Now the fourth type would be this one that goes straight across, like the opposite of this one. Goes from here to here. Goes this amount, say 1 or 2 or 3 or whatever you want. But the point is that it doesn't go up and down anything. It doesn't go up, it doesn't go down, it only goes left and right. So it would be the opposite of this equation. It goes left and right 1 here, and up and down 0, which should be this. Now this 0 divided by anything would be equal to 0 always. So our fourth type of slope would be 0, in which the slope equals 0 because there's 0 slope. It doesn't go anywhere. Now, say Martin, this guy right here, our protagonist, wants to go to, say, Slopeland. He's going to find all different types of slopes. He was going to rise. He's going to rise. Like that looks weird. He's going to rise. He's going to go up and down. Then he's going to reach a positive slope. Positive. So he's going to keep going. One must imagine Martin happy, going up this. Maybe he is going up here to take all snacks up here. Positive slope which goes up from left to right. And then next would be a negative slope. Actually, would it be easier to just show you this? Yeah. So I don't have to write anything. Right here would be a negative slope. After he gets up, he can go down like on a skateboard or something. Going from left to right, he's going down. Now from here, he's going down on a negative slope. From left to right, he reaches a 0 slope, the 4th type slope, going from here. Now if he has a slope which is undefined, which goes straight up and straight down, the opposite of this one that goes straight left and right, he might fall. Then he will run, go from left to right. Now this run and this rise is commonly what can be found in the equation of slope. The rise over the run. Rise over run, which is the equation of how to calculate slope. Changing y, how much you go up and down, and changing x, which is how much you go left and right. Now there are many different types of slopes which are always linear. For example, this one, slope. Now if you calculated the slope before, you'll know the slope. Okay. See right here, say the slope is equal to 2. Yeah, we're gonna have this equation where it's y equals 2, which is where the slope goes, and then multiplied by an x variable right here, y equals 2x. Now this is if the slope goes straight to this origin, but if it didn't, if it was like slightly to the left, right here, we're going to want to add a third part to this equation. We're going to add this, which would be plus or minus b, right here. B is going to be the y-intercept, also known as where this slope crosses the y-axis. Y-axis, this one is the x. Now see right here, it's going to cross this y-axis like 1, 2, 3, maybe 4. Like at the 4th, let me think, y-coordinate, so you're going to put 4. So you're going to see that this is the equation of a slope that would look like this. You can put it in a Desmos graphing calculator. Highly recommend it. Y equals 2x plus 4. There's 4 right here. This slope intercept would be where maybe Martin goes to take a break to eat some food, to eat some breakfast. BC is for breakfast. And right there would be where he stops. And then he keeps on climbing. He keeps on rising in a positive slope, going up, until he goes onto a negative slope, and onto a slope of 0, undefined, and so on and so forth. Next type of equation I want to talk about is actually this first one, this one's called slope intercept, because you have to know the slope of your line and the y-intercept. That's why it's called slope intercept. And then you can convert that to point slope form. This one is based on if you know a point on your line and the slope of your line. You could switch some things around to figure out where the slope intercept is. Or you can switch things around to do whatever you like. That's That's what I like about algebra. You can move things around all you want to get a clearer point of view. That's why I like geometry. Martin also likes geometry. So this is point slope form right here. Y, this is just a y variable. Just write it down, minus y1. Say, you know, a point on the line, like, say, right here. Then you have a line that goes like this. This point, let's see, is the x would be -1, and the y would be 1. So this would be, for this line right here, the slope, it would be 1 equals m. Let's see the slope of this line. Wait, do I need to... If you know the slope, this looks like it goes forward 1 and goes up 1. So the slope would be 1 over 1, which is equal to 1. So this m, the margin, the slope, is 1. I'm going to have x minus, now this is the x coordinate of the point that we have right here, which would be a -1. Now let's solve this equation together. How do I do this? Let me see. Y minus 1 equals 1 times all of this. We can convert this to an x plus 1 because two negatives make a positive. We're going to distribute this 1 over here and this. So 1 to x, it's going to be x, and 1 times 1 is going to be 1. Now this is a plus, so we're going to keep that. And we're going to see that y minus 1 equals x plus 1. Now let's see. If we subtract this 1 so that our equation is just y minus 2, because I'm going to subtract 1 from both sides. This takes away the 1 from here and takes another 1 away from here, so this would, instead of -1, -1 minus 1 would be -2. So y minus 2 equals x. Now if we take this and rearrange a couple of things, say convert it to this slope intercept form, you can see that we add 2, so this takes away this minus 2, so it's just y, and this x gets a plus 2. Now in here there's kind of an invisible 1 because x always equals 1x, always. It's gonna always equal 1x. Sometimes you just don't include it in there for simplification. Now if you can see, this is the slope intercept form. We have our y here, our slope, our x, and what's this, plus 2. Now if you look back at this, that's supposed to be the y-intercept. So we're going to have this is a +2. This is the slope intercept, or the y-intercept. If we look back at this graph that we've made, you can see that we're going to know that the y-intercept is going to be +2. And look at that. The point where this line crosses this y-axis, the y-intercept is going to be 2. Because this point has a y value of 2 and an x value of, say, 0. But that doesn't matter really much. What's important is this y equals 2. It's +2 right here. And then the third type, I'm a bit sleepy, so I'm gonna just glaze over it. It's one called the standard form. You can convert this to the standard form. Can I do that? I think ax plus by. You could subtract this, move it over to here, so that it is x, y equals 2. And subtract the y, so that x equals 2 minus y. Ax plus by. Nah, it's too difficult for me. Now, that's just one of the ways you can find slope. You can do it from a graph right here, like I just showed you. You count the change in x, and you count the change in y. You can also find it from, say, 2 points. This would be x1, y1, x2, and y2. If you put them in this handy dandy equation that I have already written down, you put the number right here, here, this here, you subtract the 2 y's, the 2 x's, and you're gonna find the change in y, the change in the x, and therefore the slope. You can also find the slope from a table, or also called a relation. And this is technically 2 points, but you can do it with more points. But this is easier for 2 points, and this would be easier for multiple. So you're gonna find a change in x from here to here, a change from y from here to here. So you already have the changes, so you're just gonna put them in the equation to change. Right here, y changes from -2 to 1, so that's +3, and it goes from 1 to 3, +2. So you go 2, 3, got the slope, 3/2. But you can also find if something is not a slope. Say if it's a curved line going like this, or this, or this, or this. You see, if change is like +2, +2, and on the other side it's going to be +2 and then +3, these two are not the same. They're, well, not the same. So the slope would not be applicable. It doesn't have slope. We're not gonna go over that right now. So, hope you enjoyed this video on all about the adventures of Slopeland. And we're gonna say goodbye to Martin, who has done a good job for us, acting as a slope guy. Show him one last time going up the slope. He's going up the slope. He's got his beanie on, his nice jacket, these rope things or whatever. And he's got a grappling hook, grappled to the top. He will be forever climbing the slope. knowing that lines never end. They go off infinitely in both directions. Thing is, I don't know how he got on this line if it never ends from the bottom or the top. So, nice video. These are my notes if you want to see them for a quick moment. This video's already half an hour long. I've been rambling. It's already more, how do you say this? More embarrassing because I've been talking for half an hour in front of my whole family. We're at a dinner reunion. Not like the place next door. What else is there? There's this. Look at this. Look at all of this. Coordinate plane. Hope you can understand all of this. I don't know if I can, if you can hear me well. I've got apartment neighbors. And, that's all, folks. See you next time.